Unsa oras sa inyong next class?
Tamo amang kay kuan. Nya pa. Hapon.
Hapon pa?
Math P, ma'am. Theoretical physics 2.
Ay, na may Math P2, no?
Yes, ma'am.
Si Sir Bien.
Yes, ma'am.
Hapon, okay. Aha naman mo sa inyong Math P2.
Talk niya about kuan, ma'am.
Isa to, Albert? Separation of variables. Gamit yapon na siya sa electromag sa chapter 3. Okay, so we will continue with our discussion on curvilinear coordinates. And last time we have started off with the spherical polar coordinates. Okay. So you have r, theta, and then we have phi. So recall that r is the distance from the origin. So if this is your point, for example, okay, so this is your point P, which can be described by XYZ in the Cartesian coordinate system. Your r is the distance from the origin towards your point P. So this is your r. And then theta is the angle from the positive z-axis towards r. This is x, this one is your y. Okay, so this is your theta. So gikan sa positive z-axis, padulong sa imo ang kining vector r, which is formed by joining the origin and your point P. So this is your theta. And then your phi is the angle from the positive x-axis towards the projection of r in the xy. Okay, so this is a projection of r in the xy plane and equal to r sine theta. Kini siya nga length diri, this is equal to r sine theta because as you can see, this is just equal to the line joining the positive z-axis diri, no? Padulong sa imong point P, straight line joining diri, padulong diri, which is just the ano siya class? Opposite side of your angle theta. So this is r sine theta. Okay, so phi is measured from the positive x-axis towards your projection of r in the xy plane. Now, when considering r, theta, and phi, we can see that r is from 0 to positive infinity. Okay, so if we have our point here, so bisag asa atong point class, our r is always from 0 to positive infinity. Or pwede po 0 to negative infinity. But kung nakay 0 to negative infinity, you can just flip your limits and then i-negative lang lang sa nimo. Okay, and then we have your theta. Kindly mute na lang kung kinsay koan. Okay, thank you. So your theta, si theta class kay gikan siya sa positive z-axis, and then your p can be anywhere, no? Imong point P kay bisag asa diri so your theta has limits 0 to pi. So from 0 to pi, or from 0 to 180 degrees. Diri lang siya, no? Diri lang siya taman. 0 to 180 degrees. And then your phi is, or it can span from gikan diri pabalik diri sa positive x-axis. So it's 0 to 2 pi, or 0 to 360 degrees. Okay, so that will be the span of our r, theta, and phi. All right, so we have also expressed our Cartesian coordinates in terms of um, the spherical polar coordinates class. So, nana na siya sa inyong note. So, dili na ko ibutang ang balik. Now, you have to take note that the three unit vectors, so nada tayo unit vectors are hat, theta hat, and then phi hat. Okay, so si r hat, theta hat o phi hat class is dili sila constant na unit vectors, di ba? Recall that x hat, y hat, and z hat are constant unit vectors, so that if we integrate, like for example, kung mag-integrate ta nga na ay mga hats, x hat, y hat, and z hat, we can actually take this out of the integral sign. Okay. However, you cannot do that for r, theta, and phi because r, theta, and phi, dili sila constant class. Okay? And then take note that r, theta, and phi points into the direction of increase of the corresponding coordinates. And of course, they are mutually perpendicular. Okay, so I'm na nato pag-show. For example, no, kini no, you can actually make a spherical surface out of this. So, maong gitawag siya spherical polar coordinates class kay. Pwede ka buhat og sphere dire of radius r. Ano siya imong radius. Tapos, ang iyaang, so this is your P. Ang R class is directed here. This is R hat. It is directed or it is pointing into the direction of increase of the corresponding coordinates. Okay, so this is R hat. And then your phi hat is padulong siya dito. Padulong siya dito. Tangent siya sa imo circular surface, sa imo spherical surface. Padulong siya dito. Tapos ang imo theta hat, ang theta hat is something like padulong siya de. Let me just pull off a figure para mas ma-visualize ninyo. Spherical polar coordinates. With saan na siya? Unit vectors. Okay, so I'm showing you my entire screen so that you will be able to see. Okay, this one. Kini siya nga figure class. Okay, so this is the spherical polar coordinate, and as you can see, muna siya okay, gibaliktad lang niya class, ang iyang theta dire is katong phi nato. Okay, so lahi iyang notation, but the same lang yapon, like ang iyang phi kay katong theta nato. So phi is the angle between the positive z-axis and your vector r. Makita ninyo class?
Yes, ma'am.
Okay. And then, si theta niya is katong angle from the x-axis towards the projection of r in the xy plane. Okay, so as you can see here, ang imuang r hat is pointing into that direction. And then, kini, this is your phi hat. Okay, so sa atong notation, this is your phi hat. Kung magbuhat kag circle, dire, kini siya class o. Kini siya nga circle. Yang nag-drawing siya circle diri as a point P. Moagi sa point P ang circle. Tangent ana nga circle ang imo ang phi hat. Okay, so again, this is the unit vector due to this or directed ani kaning imo ang phi man ni siya diri, phi man ni atong notation ani diri And then theta hat is kung magbuhat po kag circle nga moagi diri sa point P sa unsa ni nga plane. Moagi sa point P o sa z-axis, then tangent pud ana ang imo ang phi hat. Imong theta hat, sorry. Theta hat. Okay, now take note that these three are mutually perpendicular gihapon, just like the x, y, and z hats. Okay, so they are mutually perpendicular, meaning to say they make an angle of 90 degrees with respect to each other. Tapos, mag-vary ila ang direction class. Okay, so dili fix ang ilang direction, like ang x hat kay diri ra gyud sa x-axis, right? Ang z hat kay diri ra gyud sa positive or negative z-axis, ang y hat kay diri ra gyud sa negative o sa positive y-axis. But your r, theta, and phi hats varies. Depende sa imong point. Okay, nakuha ninyo? But they are mutually perpendicular regardless kung asa ang point nga imong i-consider. Okay? Klaro na ba to, class? Okay, I hope so. So, any vector A can be expressed as A is equal to AR. So this is the radial component of the vector plus A theta. So this is the polar component, theta hat, plus the azimuthal component, you have A sub phi hat. Okay? So again, this is the radial component. So A sub r is the radial component. And then A sub theta is the polar component. And then A sub phi is the azimuthal component. All right. Now, in terms of the Cartesian unit vectors, we can express this. So, pwede na siya na to ma-express in terms of the Cartesian unit vectors. Okay. So, r hat is equal to, in terms of Cartesian unit vectors. Okay, so r hat is equal to sine theta cosine phi x hat. It has three terms. Sine theta, sorry, this is theta class. Sine theta, sine phi, y hat, plus cosine theta z hat. Okay, so this is the radial unit vector as expressed in terms of the Cartesian unit vectors. And then your theta hat is cosine theta cosine phi x hat plus cosine theta sine phi y hat minus sine theta z hat. We can actually derive this one, but it would take a long time. And then we have phi. You have negative sine. You can derive this through geometrical analysis also. So you have negative sine phi x hat plus cosine phi y hat. Okay. So again, I would like to warn you that R hat, theta hat, and phi hat changes direction as P changes. Okay, so di siya parehas sa Cartesian unit vectors nga fixed, but this unit vectors changes direction. So itong isulat, no? Changes direction as P changes. So ganyan si P katong point. Okay? Meaning, if we differentiate a vector expressed in spherical coordinates, or if we differentiate and integrate, so dili siya constant, no? And then you cannot take r, theta, and phi outside an integral since they are not constant. Do not take r, theta, and phi hats as constant. Okay? Now, di ba naatay sa Cartesian coordinate system natay DL. Okay? So natay DL, naapod tay DA, naapod tay DV. Okay, so let us express those infinitesimal length, area, and volume in terms of the spherical coordinates. Okay, so let's start with the infinitesimal length or the infinitesimal displacement. Now, naka-infinitesimal length class in terms of the radial, the polar, and the azimuthal direction. Okay, so for the infinitesimal displacement element along the radial direction, r direction, so we can express it as dl of r, dl sub r. So ganun siya, infinitesimal displacement in the radial direction. So kung nakay makita nga ingani nga notation, so this is infinitesimal displacement in the radial direction. So it is just equal to dr. Okay? And then for the theta direction, the polar angle theta, so you have dl theta, which is equal to r d theta. Okay, so, and then in the azimuthal direction, so you have the azimuthal angle phi. So in that direction, phi hat direction. So ganun siya class. Ang theta hat is the direction pointing to the maximum increase. Kung magbuhat kag circle connecting or nga moagi sa z-axis o katong point P, tangent to siya ato nga circle. Okay? And then for phi hat, kini si phi hat kay kung naa kay murag hula hoop, for example, nga nasa imong hawak ang origin, so it is tangent to that hula hoop. Okay, so and it is also pointing to the maximum increase. All right, so you have this one. It is expressed as dl dl of p, dl p. This is equal to r sine theta dp. Okay, therefore, your infinitesimal displacement, dl, butang lang ako diri class ha, therefore, your dl is equal to dlr r hat, so dlr r hat plus dl theta, theta hat plus dl p, p hat. So this is equal to, sorry, okay, so this is equal to nakay dr r hat plus r d theta, theta hat, sakto ba? Plus r sine theta, d phi, phi hat. Sorry, this is phi hat. Okay, so this is your infinitesimal displacement. All right. And then we can also have the infinitesimal volume. Infinitesimal volume. So sa ganitong infinitesimal volume sa x, y, z coordinates or the Cartesian coordinates. So we have d tau. So recall in Cartesian, the infinitesimal volume d tau is just equal to dx, dy, dz. Okay. Now, for polar coordinates, for spherical polar coordinate, your d tau is equal to dlr multiplied by dl theta multiplied by dl phi. Okay, so this is equal to, so ganito, dr multiplied by your dl phi is rd theta, and then your dl theta is rd theta, and then your dl phi is r sine theta d phi. Okay, or in other words, this is r squared. So you have two r's here, multiply lang na to, no? And then you have sine theta, r squared, sine theta, you have dr d theta d phi. dr d theta d phi. Okay, so automatic. For spherical polar coordinates, you can use this infinitesimal volume. Now, for the infinitesimal surface element, it is dependent on the surface. Okay, so wala siya fixed nga form, but it is dependent on the surface. So for the infinitesimal surface element, dA, no? Katong dA class, infinitesimal. Okay. So akong isulat class para dito maglibog. It has no fixed form. Okay? So it has no general expression. So ang atong buhaton is we have to analyze the geometry. Like for example, so if you have a sphere, example. Okay, so if you have a sphere where the radius is constant, then your dA, the surface element, the infinitesimal surface element is equal to dl theta multiplied by dl phi r hat. Okay? So, kung nakay sphere, ang ang infinitesimal surface element is equal to this one. Ngano kaha class? Because r is constant. Ang mag-vary lang is this one and this one. Okay, so you have sa ganun siya, radial component lang. Nakay radial component sa imong surface element. So kung nakay spherical surface, no? Nakay spherical surface, like this one. Okay. So if you have a point here nga naa diri sa surface of your sphere, okay? Ang imong radial component is perpendicular to the surface. Okay, so it is always perpendicular to the surface. Meaning to say, kini siya 90 degrees ni siya diri with respect to the surface. 90 degrees. Okay. So this is your A class nga gi-consider. Magkuha ka diri og A, gamay nga area. So ang meaning aning infinitesimal surface element class, magkuha ka og gamay nga area aning nga surface sa imong spherical surface. Now take note that the area vector is perpendicular to the surface. It is directed here. The same with that of the radial component of your polar coordinates. Okay, so katong mga theta hat o phi hat mag-vanish to siya. Okay? So kini siya perpendicular. This is your dA because again, your area element kay kini siya no mo ni siya imong area element mo ni siya si dA. Ang iyaang direction class is perpendicular to the surface. So kung kini mong surface, then perpendicular ana. Okay? Now it is, sa ganito, it is parallel to your vector r hat. Okay, that is why ang mahabilin lang nga term. Supposedly, nani siya tulo ka terms dire, na ay theta hat o katon apoy phi hat. But kini lang siya ang dili mag-vanish. Okay? So for your sphere, you have this is r d theta. And then your dl phi is r sine theta d phi. Okay? So take note of this because we will be kasagara gid atong gamiton nga surface class kay spherical surface. So you have r squared sine theta d theta d phi r hat. Okay, so this is your surface element for a spherical surface with constant radius r. All right. Now, how about if you have a surface that is in the xy plane where theta is constant? Okay. So another example, example 1, example 2. So what unsa daw imong surface element if you have a surface that is in the xy plane where theta is constant. Okay, so for this, your dA is equal to dl r dl phi. Okay, so constant man si theta. So you have here theta hat. Okay, so murag dali ra gyapon siya i-determine kas kung unsay constant mo to siya nga component ang mahabilin. Okay? So if you have dlr, you have r, this is dr, dlr is dr, and then dl phi is r sine theta d phi. Therefore, for this surface in the xy plane, hagay ng xy plane, okay, so kung sa kuan pa, kung z kay pasaka vertical, xy plane kay kining floor, okay? So you have r dr, let us write it this way. So although correct gihapon to siya. So you have r sine theta dr d phi. Okay? We forgot to write theta hat. Okay? So this is for a surface that is in the xy plane where theta is constant. Nganong theta is constant man class pag na siya sa xy plane? Okay, theta is constant kay ngano ganito ang theta is measured from the positive z-axis towards dire sa projection ni P along the z-axis. So automatic this is pila man ni 90 degrees. Okay. Any questions so far, class? La, napa mo?
Yes, ma'am.
Okay, so wala questions, no? Let us express the vector derivatives in terms of the spherical polar coordinates. So this is getting, sa ba? Murag exciting na ni siya nga podcast. Spherical coordinates. Okay, so for the gradient, for the gradient of a scalar function f, you can express it as this. So you have kadumdum po mo sa expression sa gradient in terms of the Cartesian coordinates. Okay. So dili to siya ninyo dapat limtan kas. We have 1 over r partial derivative of the function with respect to with respect to theta, theta hat. And then the last term is 1 over r sine theta. Feeling na ko kay na-derive na po ni siya ninyo sa inyong mathematical physics. Phi hat. You just need to review your notes sa math phi class. Okay. So, basig matingala mo anong naing-ani siya. So, this has been derived from the Cartesian padulong diri sa kini spherical coordinates. And then for the divergence of a vector function, so you have the divergence of v. This is equal to 1 over r squared multiplied by the partial derivative of r squared multiplied by the radial component of your function. Okay? Plus 1 over r sine theta multiplied by the partial derivative with respect to theta of sine theta v theta. So take note class that kini sila nga mga kini siya kay nani kani ang mag-change lang diri kay si VR kung depende sa imong function. But kini siya, this is naana ni siya sa imong equation. Okay? So dili ni mawala si r square dapat. Usahay kay dili ta marong kay malimtan usahay si r squared, kini si sin theta malimtan o kini nga mga factors. Okay? Sin theta v theta plus the last term is 1 over r sine theta multiplied by the partial derivative of the azimuthal or kini siya nga component, phi component with respect to phi. Okay, so this is the divergence in terms of the spherical polar coordinates. And then for the curl, you have the curl of the vector function v is equal to, this one is very long. So it's 1 over r sine theta multiplied by the partial derivative of sine theta v phi minus the derivative of v phi, v theta rather. Sorry, this is v theta class with respect to phi. So this is the radial component plus 1 over r multiplied by this quantity. You have 1 over sine theta, the derivative of v sub r over d phi minus, i-check lang ninyo class ha, sa inyong math phi kung basig natay na mali diri nga mga kuan. You have r v phi. So this is your polar component. And then the last term is, you have this one, 1 over r multiplied by the partial derivative with respect to r of r v theta minus the partial derivative of v sub r with respect to theta. So again, this is getting exciting. This exciting na nga podcast. How about the Laplacian? So for the Laplacian, okay, ito. So the Laplacian of a scalar function, so you have 1 over r squared, and the partial multiplied by the partial derivative of this term plus 1 over r squared sine theta multiplied by the partial derivative with respect to theta of sine theta multiplied by the partial derivative of the function with respect to theta. And then we have 1 over r squared sine squared theta multiplied by the second derivative of t with respect to phi squared. Okay, so this is the Laplacian of a scalar function. Okay, so balikan na ni siya na to later class. We will have examples on this. And then for now, we will express also in terms of the x, y, and z coordinates. Express na to si r, theta, and phi. Okay? So your r is just equal to the square root of x squared plus y squared plus z squared. Okay, so if you are given with the x, y, z coordinates, you can actually get the r. So once again, si r, this is the length of the line joining the origin and your point P. So you have this one. And then your theta can be obtained using this. You have the inverse cosine or the r cosine of z divided by the square root of x squared plus y squared plus z squared. Or this is just equal to the cosine inverse of z. This one is just r. Z over r. Okay? And then your phi class is equal to the inverse tangent of y over x. Okay, so remember that your angle phi is just in the xy plane. So nara ka sa xy plane. So you have this one. Tangent inverse of y over x, the same as that of katong determining the angle sa katong vector gani class y over x. Okay, and then kaganina murag atong gi-express ang radial, the spherical unit vectors in terms of the Cartesian unit vectors. Okay, so now let us express the Cartesian unit vectors in terms of the radial unit vector. So, okay, so Cartesian unit vectors in terms spherical polar coordinates. Okay, so you have x hat. Your x hat is just equal to murag wala ba ning kaganina class? It's not. So this is different. Sine theta cosine phi r hat plus cosine theta cosine phi theta hat minus sine phi hat. Okay, so this is your x hat. And then your y hat is equal to sine theta sine phi r hat plus cosine theta sine phi theta hat plus cosine phi hat. And then lastly, your z hat is just equal to cosine theta r hat minus sine theta hat. Okay. So, I don't know kung ma-memorize ba ni siya na to class, but hopefully. All right, so let us have some examples para ma-imagine gid siya nato and mas masabtan nato no ang ato ang concept. Okay, so example, dito magamit ato ang mga gipang sulat. Examples. The first example is this. Check the divergence theorem for the function so we are given with this vector function v equal to v sub 1 equal to r squared r hat. So it only has a component along the r hat direction. Using as your volume the sphere of radius r centered at the origin. Centered at the origin. Okay. So recall that the divergence theorem states that the integral of the divergence of v d tau is equal to the surface integral of v dot dA. All right. So we are given with this function, r squared r hat. So first thing to do is to find the divergence of v. Okay. So the divergence of v is equal to radial naman yung component. Sa ganito class, sa ganito kaganina, the divergence of v, this one. So since we only have a radial component, then makopy ba rin ito? Dili, no? Dili siya na ito. Makopy text box na ito. Okay, so you have this one, kani. 1 over r squared, partial derivative of r squared vr with respect to r. Okay? So, kato lang siya, 1 over r squared, partial derivative of r squared multiplied by v sub r with respect to r. So, this is equal to 1 over r squared. You have r squared multiplied by this one. V sub r is just equal to r squared. So you have 1 over r squared partial derivative of r to the fourth. So this is easier. 1 over r squared. Derivative of this is, so ang ganyan siya class, 4r cubed. Sakto ba? 4r cubed, right?
Yes, ma'am.
Okay, and then we can cancel some r's here. 1 over r squared, i-divide lang to si 4r cubed divided by r squared. So we are left with 4r. Okay, so this is the divergence of v. Now, let us evaluate the left-hand side of the equation. So the integral left-hand side. So the integral of the divergence, the volume integral of the divergence is equal to, you have 4r, your d tau. Kadumdum pa mo sa tong d tau, class? D tau is r squared sine theta dr d theta dphi. Ano ba tayo nalimtan? Okay, so this is our r squared. So we will have volume integral. Now, in order for us to evaluate the volume integral, we need to consider the volume. So, aham ni siya na to integrate. So, as your volume, the sphere of radius r centered at the origin. Okay, so muna siya ato ang murag boundary. Okay, so we have here the integral of 4r cubed sine theta dr d theta d phi, or we can rewrite this. This is actually a triple integral because we are integrating with respect to some volume. So you have, ipagawas lang ako daan si 4 because it is a constant. So you have r cubed, r cubed dr, integral of sine theta d theta, sine theta d theta, and then we have d phi. Okay, now for the limit, the radial limit, it is from the origin towards your radius, the radius of the sphere. So you have from 0 to r, and then your sine, your theta is from, since we are considering the whole sphere, your theta, class, is from 0 to pi. 0 to 180 degrees, because remember that your theta can span from the positive x-axis padulong sa negative x-axis. This is z. From the positive z-axis towards the negative z-axis. So this is 180 degrees, or that is equal to pi. So mulang ni siya ang limit, no, from 0 to pi, or 0 to 180 degrees. Since we are also considering the whole volume of a sphere. Okay? And then your phi is from, gikan siya sa x-axis, padulong sa, balik sa z-axis. So, sorry. Gikan siya sa positive x-axis towards balik sa positive x-axis. So, that is from 0 to 360 degrees, or that is equal to 2 pi. Okay, so evaluating, you have 4. This is r to the 4th over 4. Sakto ba, class? From 0 to r multiplied by, unsa gani integral of sine theta? Negative cosine, no? Negative cosine theta integrated from 0 to pi multiplied by the integral of d phi is phi, which is 0 to 2 pi. Okay, so you have, saan man siya? Yeah, we will evaluate this. 4 multiplied by r to the 4th over 4 minus 0. Tapos you have negative cosine pi minus negative cosine 0. And then you have 2 pi minus 0. Okay, so you have 4. We can cancel this out. Sorry. Tama ba? Makancel na ba ni siya na to, no? So you have r to the 4th. And then, how about this one? Negative cosine 180 degrees, negative cosine pi. So when you're using pi, you have to make sure that your calculator is in radians mode. So cosine 180 is negative 1. So may mo siyang positive. Negative 1 times this negative sign here, it will become positive 1. And then, kini siya kay plus cosine 0. So, cosine 0 is 1. Ito ba? R to the fourth plus 1 plus 1, that is 2 multiplied by 2 pi. Okay, so for the left-hand side of the equation, this is equal to, dali lang natin isulat class, 4 pi r to the fourth. Okay, so this is for the left-hand side of the equation. Now, let us go to the right-hand side of the divergence theorem. So right-hand side of the divergence theorem, in which we need to do surface, surface integration. So you have v dot dA is equal to the integral of, so itong v na to, r squared r hat. Okay, so r squared r hat. So all other terms will, sa imo ang dA class, supposedly na siya tulo ka terms. But all the other terms will vanish because this is dot product. So ang mabilin lang kay katong r hat pod nga component. So na kay dl theta multiplied by dl phi r hat. Actually, kay ato na ni siyang na-solve ka ganina for a sphere. So na kay r squared r hat dot with pwede na ito kwaoning kuan r hat class. So multiply na siya nato diretso. So the dot product, we will eliminate this. So na kay r squared from here, and then diri ang sa ganin ni sa class, dl theta is r d theta, and then your dl phi is r sine theta d phi. Okay, so you have integral of r to the fourth, r to the fourth. Sakto ba? R squared, napo kay r diri, napo kay r diri. R to the fourth sine theta d theta d phi. Okay? Where, since atong gi-consider kay ang surface man ni surface element man ni sa class, surface element dA. So, for example, diri ka magkuhag surface element. Okay? So, from the origin, kabalo na ta, bisag asa sa surface sa sphere, bisag asa ka magkuha og surface element sa surface sa sphere, ang ang r ana class is constant, which is equal to the radius of the sphere. Okay? So, r is equal to the radius of the sphere. It is constant, so we can actually substitute it here. So you have r to the fourth sine theta d theta d phi. Okay, so this is surface integral r to the fourth integral of sine theta d theta. Again, this is from 0 to pi, and then your d phi, your phi is from 0 to 2 pi. Okay, so you have r to the fourth multiplied by sine theta d theta. This is equal to negative cosine theta from 0 to pi. And then here you will get 2 pi also. So kini siya pareharan ni kaganina. Negative cosine pi minus cosine minus negative cosine 0. So we will get also 2. Evaluating this, you will get 2. So you have r to the fourth multiplied by 2 multiplied by 2 pi. So you have 4 pi r to the fourth. Okay? So this is the right-hand side of the equation. Therefore, the divergence theorem, the d tau is equal to v dot dA. Okay? Any questions? So we have verified the divergence theorem for this so dito, for this vector function v sub 1. Okay. Let's have another example class. This one is somewhat controversial, but so example number 2. Okay. So let us do the same for v sub 2 equal to 1 over r squared. So kaganina r squared to no? This time 1 over r squared r hat. So kini si 1 over r squared r hat class. Favorite gid kay ni siya sa electromag because yeah, ang ato ang electric force as well as electric force and electric field are dependent on r hat, inverse square of the distance. Okay. So you have this one. Let us get the divergence first of this vector function. So the divergence of this is radial naman po diyang component. So you have 1 over r squared. So ganito, d r squared over dr, sorry. So you have r squared multiplied by 1 over r squared. Sakto ba? So this is our, muna siya itong VR, no? This is your VR. Okay, so you have 1 over r squared multiplied by partial derivative of r squared multiplied by VR, where our VR is equal to 1 over r squared. Okay, so for this, we'll answer class. 1 over r squared, partial derivative with respect to r of, you have r squared over r squared, that is equal to 1. What is the derivative of a constant? Hello? Albert?
None.
Derivative of a constant is equal to?
0, ma'am.
0. Okay, very good. So this is equal to 0. Meaning to say, when we get the left-hand side of the divergence theorem, you have the integral, the volume integral of this, of 0 with respect to theta, we will get 0. Okay. Now, how about the right-hand side? So the right-hand side of the divergence theorem states that v dot dA, you have this one, v dot dA. Now, this is for a sphere, I think, gihapon, yes. It is for a sphere of radius r gihapon. Okay, so sphere of radius r. All right, so your v is 1 over r squared. So you have the integral of 1 over r squared. And then your dA is again equal to r d theta. And then r sine theta d phi. Okay, so you have 1 over r squared, integral of 1 over r squared. You have r squared sine theta d theta d phi. So you have the integral of sine theta d theta. Ay makancel out man ni si r squared. And then another integral for phi. So you have 0 to 2 pi. This is 0 to pi. And then this one is 0 to 2 pi. Okay, so you have, again, kabalo naman taning class, no? Actually kay kini siya class kay nani siya term sa advanced nga electromag murag gitawag ni siya og ano sa to? Solid angle. Solid angle equal to 4 pi. 4 pi siya kay ngano ganini kini siya kay 2 man ni siya diri. Kini pud siya kay 2 pi so na kay 4 pi. Okay? Now take note that the left hand side is not equal to the right hand side of the equation. So they do not agree. There is a discrepancy. So how do we ang question kay dili di ay always true ang divergence theorem. Mo yan na ba kana? Magduda ta sa divergence theorem based on this result. So unsa kay explanation ani class? Okay. So as you can see, wala gid sila nag-agree. 0 ang left-hand side, 4 pi ang right-hand side of the equation. Okay. Ano ka nino? Okay. So for this, para kay 1 over r squared, kabantay pud matong previous na tong result. Di ko sure class kung gihatag ba to nako as an example or as an exercise nga atong katuganing sa ganito. When we check sa nako ang notes ha. Murag nato sa notes class, di ko sure kung nahatag ko na ko sa inyo or okay. So kadtong kaning pinakauna pa divergence, like for example, nakay point tapos di ba ing-ani man imong 1 over r squared expectedly ing-ana siya. But when you calculate the divergence of 1 over r, yeah, like this one, kini, kuha nimo ang divergence sa 1 over r, imong nakuha kay 0. Okay, so, kung mayon kag divergence is equal to 0, meaning wala ing-ani, wala ta na ing-ani, no? Ay mo man siya ang picture or illustration sa nag-diverge from a single point, gani siya nga point. Okay, for example, nakay point charge ang electric field kay mag-diverge siya or diri from this point. Okay? So surprisingly, mo ni siya tong expectation for katong 1 over r squared, but as you can see, it has no divergence. Okay, so this discrepancy can be solved using the Dirac delta function, and we will be able to discuss this, I think, sa next meeting pagid kas murag last na ni siya nga topic sa chapter 1, the Dirac delta function, which is a very beautiful function. It answers this discrepancy. Okay, so tuli ka ng kini siya nga result, murag it gave way to the Dirac delta function. Okay, so for now, we will have another example. So napamantay 9 minutes. We can have one last example class. But this is, I think, quite long. So kung dili na to mahuman, ato lang po na yung humano ay i-continue next meeting. Okay? So compute, for the third example, you have to compute the divergence of the function. Okay, so medyo taas din siya. Compute the divergence of the function which is given by this. So you have your vector function r cosine theta r hat plus, na may assignment, r sine theta hat plus r sine theta cosine phi phi hat. Okay, so this is your vector function. So you have to check the divergence theorem for this function. Check the divergence theorem. So, kini siya nga example class. This is to illustrate nga dili lang daay spherical surface or katong sphere nga volume atong gamiton always. So, check the divergence of this function, the divergence theorem for this function using as your volume the inverted hemispherical inverted. Of radius r resting, sorry, resting on the xy plane. On the xy plane. And centered at the origin. Okay. Again, kini siya class kay magamit ni siya to determine our boundaries or katong limits. Okay? Kung sa may nawong aning inverted hemispherical bowl of radius r. So, mura siya ingani class. Ito ko bala mo drawing. Mura lang siya og bowl nga gitaklob gani class. So, ano siya pag-drawing nga ana? Something like this. Okay, so mura siya yahong nga gikulob. Now, ang iyang kini siya nga surface, kining murag naa siya sa xy plane. Tapos ang iyang radius is r, big R. Meaning diri iyang radius r. Tapos of course from the origin towards any surface sa imo bowl, this is also r. Okay? So, di ba, kung nakay bowl, na siya circle, na siya circle sa mouth, ini siya, yung nabaliktad nga mouth kay circle na siya, tapos kanina yun. Okay. And then, so let us check the divergence theorem for this function. So, again, ang pinakauna na to buhaton class is to find the divergence or to compute the divergence. First is to compute the divergence of the vector function. So you have, okay, so sa may divergence ani. So you have 1 over r squared, partial derivative of r squared times VR plus, sige ito class, 1 over r sine theta, 1 over r sine theta, the partial derivative of, with respect to theta, of sine theta times v theta plus 1 over r sine theta, the partial derivative with respect to phi of your v. Okay, so let us write this one. Ito lang ni i-substitute ng mga component sa imong vector function. Alright, so we have 3 minutes. So you should help me with this. You have 1 over r squared, partial derivative with respect to r of, so ganito itong VR class, it's r cosine theta plus 1 over r sine theta partial derivative with respect to theta of sine theta multiplied by your v theta. So your v theta is r sine theta. And then lastly, you have 1 over r sine theta. Your v phi. So your v phi is r sine theta cosine phi. Ay, we forgot the partial derivative with respect to phi. All right. So from here, evaluate lang tayo na to ang integral. Can you do this, class? Can you do this? So ang hint, since it is, sorry. So maraman siya, half lang siya sa sphere, di ba? Ang sphere kay, yeah, it's hemisphere, so half pa siya sa sphere, class. Now, for your volume integral, the radial component is from 0 to r, and then ang polar component is from 0 to sa class, dili siya taman, dili siya 2 pi. Dili man siya whole na sphere. So dili siya taman no, from the positive z-axis. From the positive z-axis towards dili sa surface. Yung circular surface sa ilalom. So this is equal to patunga sa 180 degrees, that is 90 degrees, or in radial, it's pi over 2. Radian, it's pi over 2. So hint, r is from 0 to r, and then your theta is constant. So it's from 0 to pi over 2. So volume integral ni siya na class now sa left-hand side of the equation. And then your phi is from 0 to 2 pi. Sa area, sa surface element, you have two surfaces. Consider two surfaces. Haman ani nga surface atong i-consider. Pareha bito atong cube nga atong buhat last time class, surface integral na kay cube. So ang atong i-consider is kani siya, and then kini pong circular surface diri sa ilalom. Okay, so you have to consider two surfaces. And for that two surfaces, lahi-lahi mo ang dA. So na kay dA1 and dA2. So you have two surfaces, na po siya corresponding area surface element, dA1 o dA2. Okay, so this is your assignment class, and you can submit this. You can work on it since wala man daw may klase karon whole morning, so you can work on it now, and then you can submit it anytime on Thursday. Okay, so lakaron pa ko nakabasa, Cherry, sa imo ang message. Okay. So see you on Thursday class. We will have online lang gihapon class para daghan tang ma-discuss. Actually kay gamay na lang gyud ang chapter 1 tapos maka-electrostatics na ta. Okay? So do you have questions?